I got a couple of handouts here on subsurface placement, so kind of pass those around. I did not print off enough, so if you don't get one and you want one, they're going to be at go.osu.edu/subsurface. So if you want to write that down, I'll put that up at the end of my presentation so you can have that link. But today I'm mainly going to go over our work with subsurface placement and kind of stay broad and talk about the tools that are available and the implementation for the farm. So we're just really getting into the digital ag program and our applications, moving some of those subsurface, and we're really liking the results so far and have some interesting trials planned for 2018. But first, a little bit about me. I'm originally from Alabama, so if you pick up an accent, that's why. But I graduated from Auburn University and then came up to work with Dr. Fulton in the digital ag program here. So we're pretending like we're OSU fans. This was at the this was at the Penn State game. So after that game, I became a little bit more of a Buckeye. So, but I'm really interested in digital ag technologies, and really part of my passion for those technologies is being able to make data-based decisions that impact you guys and your bottom line, and because really profitability is the name of the game. And we think we have some opportunities here by using subsurface placement to impact the profitability and to also do that in a way that impacts the environment positively and in some cases can help our yields. So I have a couple questions throughout the presentation. We're using an app called Slido, but you can also go to slido.com if you would like to participate. This is just a pretty easy way to get some feedback from you guys, as well as for us to see how your operations are going and what your thoughts are for the future. So if you take a second just to go to slido.com, and then you can enter the code. It's CTC 2018. And then you enter that in, and as the questions pop up throughout the presentation, you'll be able to respond to those. So we have our first question. We'll do a tester, and for this question we're asking, did you place any nutrients subsurface in 2017? So we're not saying specifically here that you're doing a subsurface application per se, but that could be anything, planter applied, side dress applications, anything like that. So we'll get some answers in. And it looks like everybody is. So 88% of you put some type of nutrients below the soil surface in 17. So that's encouraging. And there's a lot of reasons for that and for the push for positive nutrient management throughout Ohio. And I think everyone's aware of that. Obviously we have some nutrient concerns throughout the state, and everybody here feels pressure, and everybody outside of agriculture also feels that pressure. But primarily, there's two ways that these water quality issues come up. And that's through nutrient runoff, and then also we know that some of those nutrients are tied to soils. So so the soil erosion from the fields is also influencing the water quality issues. So this was from 2017. So we can see as the years have gone on, and probably our nutrient management practices have gotten better, there's still some issues available or that are persisting in the lake. So I wanted to pull this one in. This was from 2013, and I wanted to emphasize the difference here, and that you can see a good brown tint to some of those the inlets to the lake there. So that can speak to the amount of soils that's entering the lake. So when we think about subsurface or the nutrient concerns in Ohio, I have another question here, and that's which method of water loss from agriculture has higher nutrient concentrations? So if I have a gallon of water loss from a field, which has more concentrated nutrients, the overland runoff or drainage from subsurface drainage? So I'll take a second and let y'all answer that question. But we've done a lot of work with the NRCS around, there's a a base out of Columbus with the Kevin King. They do a lot of great water quality research, and they've pulled some really great data related to overland runoff and subsurface drainage, and we've been able to see the nutrient concentrations and total loads. So it looks like about 75% is saying overland runoff, and that's correct. So the overland runoff that we've seen from data that provided by the NRCS has higher nutrient concentrations. And why is that? Well, there's two main methods of overland runoff nutrient loss. The first of which being the particles being exposed on the top of the soil surface, which I think everybody is aware of. And the second is the stratified soil erosion. So some of our broadcast applications, maybe a no-till environment, similar to those conditions, we can build a nutrient layer in those top few inches of the soil that's really concentrated. And that becomes kind of a hot zone in the soils there. So, and then we also have losses through subsurface drainage, and there's two methods mainly that nutrients are lost through subsurface, and that's primarily through macropore movement. So what we mean by that is earthworm holes or cracks and fissures in the soil where those particles that are sitting on the soil surface are being taken straight down to the drainage tile, and then that is carried through the tile to the outlets. But then also traditional drainage where the water is infiltrating throughout the soil profile and being carried to our outlet drains. So this was all work done by the NRCS station and that's housed in our department. And so they've been able to really provide some great data and justify why subsurface placement would be a good fit for Ohio. And but then it's our job to be able to tell you as producers that it can also be profitable. It's not just about the environment. It's, at the end of the day, we're the ones that's in the field. And so today we're going to kind of outline some of the tools available to you to be able to remedy some of these issues. So this is just a picture of the overland runoff. We can see it's more concentrated, and we're seeing that from the particles and then also from the highly stratified soils. So this is an image of particles sitting on the surface after a broadcast application, and they also did some work with the USDA on, they put MAP 1 centimeter below the soil surface. Is anybody incorporating that 1 centimeter? That's only, just a very little bit, but it reduced the nutrient concentrations of that runoff by 98%. So that really speaks volume to the ability of how those nutrients are really reduced by just a simple incorporation. But we also know that we're building, in some cases, stratified soils in our operations. So this was some work done at Farm Science Review, I believe it was 2012. They took some soil samples and stratified them. So we took the 0 to 2, 2 to 4, and so on in our soil cores and just looked at the phosphorus. What we found was 57% of the phosphorus for that whole core was in the top 2 inches. And so we know that from some of our applications, we're losing some of that soil that's very highly concentrated. So another method of loss would be through the macropore movement. So this was a study done by the USDA, and they took 3 different methods of fertilizer application: broadcast, injection, and broadcast with tillage. And they were able to look at movement throughout the soil profile. They installed some lysimeters, which is a device that can measure the infiltration, and they looked at that and saw that the broadcast applications had higher concentrations. And why is that? Well, if we think about it, if the injection and tillage operations have less concentration, then possibly those macropores are directing those fertilizer particles straight down to the drains. So that was some work that kind of pointed towards macropore movement. We also know that drainage has some effect also, and those nutrients seeping down throughout the soil profile. But with traditional drainage, you have that time for the water to infiltrate through the soil and for some of those nutrients to be absorbed during that process. So we know why all these things are happening, but what's our traditional nutrient management practice it's going to differ from farm to farm, and everybody has a different management strategy. But in practices that are intensively broadcast, and we know that no-till soils or minimum tillage soils, we really start to build that zone of stratification. So what are some tools that really enable us as producers to do a better job from a nutrient management standpoint? So that's one of the questions that we've had over the past few years, and how can we provide you with the best tools to really facilitate that positive nutrient management in the future. So what we found was there's a lot of different options to place fertilizer below the surface, and there's tools dedicated specifically to that, but also we have opportunities for a spread and incorporation, which we know some people doing, and then we also have opportunities to put that fertilizer on with the planter. All these being ways to put it just a little bit below the soil surface, but then we also have culture systems that are able to do injection type of application, and then we also have some equipment that's dedicated where its purpose is to put fertilizer below the surface. So this last category is what we tried to kind of highlight over the past couple years and really understand what these type of equipment options are, and then how they can be implemented into farms throughout Ohio. So we know that all these are opportunities that we can use to put fertilizer below the surface, but we want to specifically outline some equipment for y'all to be able to understand what's available on the market and how that can be implemented in my operation. So one of the things that when we first started out, we said, what are we trying to do with our subsurface research here? Well, and how is it, what is a good strategy for understanding the subsurface adoption? Well, first of all, we need to meet our fertility needs of the crop. That's pretty plain and simple. But also we want to try to reduce our inputs, possibly, by using progressive strategies like variable rate and dual product applications, and understanding how those affect the effect of those on our crop health in a subsurface environment. Because that drastically changes. We probably have pretty different nutrient uptake between broadcast application and subsurface. So we also wanted to assess the environmental impact, just because of the nature of the environment here in Ohio, and to understand how those tools can positively impact the environmental side of things. But this is really tough, right? We only have so much time between harvest and planting, and it's hard to get in the field again. Being from Alabama, I didn't really have to worry about fields freezing up in the winter, but find that to be very different when I come up here. So you got to think about a lot of things when you're trying to look at subsurface placement. You got the environmental aspect, you minimize variability in your field, provide optimal nutrients to your crop, and then at the end of the day, all those factors combined, you have to be profitable. And that's really hard to do. So throughout the rest of the talk, I'm going to outline some equipment options that we found, and then we can analyze those tools and really see the opportunities we have for building a good seed environment. Because that's where it starts. That's why we fertilize. That's why we perform any type of tillage, is to create the best seed environment possible for that spring planting. And then we'll look at a little bit of the implementation and how you can adopt these tools in your operation. So we've done a lot of categorization of these tools and really tried to define the functionality of different tools available on the market. So really, a lot of these tools come down to two components, the first being the ground engaging implement, and the second being a fertilizer applicator. And primarily, their ground engaging implement really determines the final placement of those fertilizers in the seedbed environment, and influences how the seed will function with those fertilizers. But the applicator is responsible for the metering and distribution of those fertilizers. So that corresponds to the rate and then also the placement, because these distribution systems can function differently from system to system. So we're going to look at both of these, and there's a lot of opportunities for customization of both of those. So you can take a fertilizer applicator on one machine and swap it over. There's a lot of chances for you to build a rig or possibly implement tools in your operation that aren't standard. So kind of what we separated the ground engaging implement side of things, we separated that into three main categories. And again, this is looking at subsurface application equipment only as an opportunity to really adopt these tools. So the first of all is kind of a shank style strip till operation, and that would be we like to call it a deep rip and placement category. And so typically these implements are running anywhere from 4 to 12 inches deep, and the ability to place fertilizer anywhere through there in a concentrated band. And typically they have about 40% or less disturbance. So we like to include this in our presentations because there's a lot of tillage preferences across the board. But usually these strips are somewhere about 8 inches wide, 8 to 12, somewhere in there. And then the rest of those in between the strips are left in a no-till environment. So the second category is more of a zone mixing with fertilizer injection. Some of these row units, maybe like Dawn or ETS, also provide some type of churning action. A lot of those coulters are really ripping, and usually you use an environment kind of 0 to 5 inches or so, and are really mixing fertilizer into the strips. Those are also around 40% or less disturbance and provide a good zone of a good seed bed that is available for planting the next fall. So a lot of guys we talk to, they say, oh, 40%, 30% tillage, that's way too much. So there are new tools out. There's Deere and Case, and a lot of other manufacturers have put out high-speed injection tools, and a lot of these have just a slight opener and able to run about 10 to 12 miles an hour through the field to really get that application in before planting. Usually about 15% or less disturbance. So in a no-till environment, a lot of guys like that opportunity, especially because of the field capacity that goes along with it. So when we talk about the surface disturbance there, but in the subsurface disturbance, this is what we've kind of looked at in a way that we really want to understand the seed environment. So we're able to take a cross-section of these strips, or in the case of injection, take a cross-section of that and see their zone of influence. So we can see with the deep rip and placement environment, we're really looking for a U-shape, a good shatter zone of any compaction that may be down in that layer, and then also being able to place a fertilized band at a specific spot within the strip. So some of those opportunities some of those tools are available to place fertilizer at different depths regardless of where the shank is, which is the tool that we run. We can have the shank set at a certain depth and move the fertilizer application opener up and down. With the zone mixing type of implement, we really see a turning and mixing in of fertilizer into the strips and distributing that fertilizer throughout. So we're able to create that seed bed in the 0 to 6 inch range, depending on your soils, and to mix that fertilizer in before planting. The high-speed injection, we're putting that band in. You can see the slight opening where we're just basically opening the soil, injecting, and closing it back up. So there's a lot of these tools that are being developed and coming out with in the industry and across the board that we're seeing a lot of guys adopt as a way to move applications to subsurface. So let's do another Slido question, wake everybody up. Which equipment style is most suitable for use on your farm today? So we also put up on this one the broadcast and incorporate. But remember the deep rip and placement or shank style of strip till. Then we have the zone mixing or kind of the coulter style of strip till. And then we have the high speed injection placement. So take a second and answer that. Let's see what our results are. Okay, so it looks like we got about 35% that broadcast and incorporate right now, and about 31% of the deep rip and placement. So it's kind of jumping all over the board here. A lot of people like the injection placement also. probably because of that field capacity. You don't have to go 4 to 5 miles an hour. You can pull it more 10 miles an hour. But all right, looks like our winner is going to be broadcast and incorporate. And so maybe that's the option for your farm. But the main goal here is that we're outlining the tools available for you, and any possibilities that we have to do subsurface placement. So broadcast was the winner. Then we'll talk a little bit more about the influence of that and the incorporation, how that affects the seed bed here in a second. So to summarize, these are the 3 categories again, and these are in the pamphlet that I handed out, but also they're available on our website. I'll provide a link at the end where y'all can access that. So the second component of our subsurface application system is the nutrient applicator. And this can really vary from grower to grower in their terms of preference and the ability of their farm to access these fertilizer sources. So the first of all, it being dry, and we've seen the ability of some of these applicators to do multiple products, independently metered or metering of 2 blends, really customizable. And then we have the liquid application systems, which are also pretty popular in the ability to inject that liquid into the strips or at high speeds, depending on your implement. There are also some opportunities for anhydrous incorporation in some of these tools. These are pretty specific on you kind of have to have an applicator that matches up with your ground engaging implement, because some of the implements are change in functionality between the sources available to place below the surface. So just consider that when you're shopping around for options. Find tools that work together. That's a pretty simple thing to ask, just to take a glance at the toolbar and see if that's capable of that. But the other component other than the source is the metering aspects. So typically when we talk about metering, you're thinking about granular fertilizers, but also just the effect of metering liquids or the application or monitoring of anhydrous applicators. But we really like tools that are available today that are able to place products at a variable rate and a dual product. Some of those options really provide customization that we like in our nutrient management strategies. So for example, this is a field that we'll be applicating this spring, and you can see we're doing a MAP application through a granular tool that we're able to actually cut down a lot of rates due to our soil sampling protocol, and we're actually applying 8 pounds an acre average across the field, because we know from our intensive sampling that we can cut out a lot of that field in terms of P application. So really looking for something that's customizable and fits your goals as a grower, your nutrient management goals. That's really the goal here, is to find a tool that suits you and your operation. So when we talk about the applicator, some of the things we like is the ability to accurately hit a rate and to understand the rates as they change across the row to row. We've done some work there and been able to see the ability of these tools to hit an accurate rate and hold it throughout the field, and then also to perform an accurate blend. So if we're doing more than one product, you think about these distribution systems, no matter what source you're using, each one of these rows has a different length of travel from the applicator to its final destination with the implement. So we just have a simple 8-row machine, and on the outside rows, that fertilizer has to travel 14 feet, where the rows in the middle only have to go 8 feet. So understanding how the distribution and metering affects your final placement and rates that are applied is a good thing to know when you're adopting a new tool or thinking about adopting a new tool. So we've done a few tests with different manufacturers and the ability of fertilizer to keep an accurate rate, and we've seen good rates there. We just did a simple test with a 150-pound potash application and looked at the variation across the rows. Within 20 pounds an acre, we really liked that. There was 1 or 2 rows that were down, but for the most part, we're keeping and holding an accurate rate. So these tools are cutting-edge technology. They're able to function at a very high level, and and we're seeing some good results from incorporating them. So now we talked about the tools and outlined how they can be used, but let's go back to the why in the seedbed environment. So we're really interested in providing the best seedbed that we could possibly make before our planter pass. And you guys know this, but through our subsurface applications, we're really trying to optimize our nutrient uptake. And then we've also seen some opportunities for improvement of planter performance. Depending on our type of tillage instrument that we use for this subsurface application, we can evaluate the planter, because that changes how we're going to plant. And then we're also going to look at the effects of soil compaction, and some tools provide an opportunity to relieve some of that. So we did a little case study last year at one of our research farms in South Charleston, and we took our shank-style strip till, or our deep rip and placement implement, and we ripped it up at 8 inches, because we did some penetrometer measurements, and basically that measures the compaction throughout the soil profile. It's a probe that you stick in, and you're able to see your levels of compaction as you go down. So the left side is our no-till environment, and what you see there in the red is compaction levels that are over 200 psi in force to be able to fit that cone down through the soil profile. And we know through previous research that anything over that point is detrimental to crop yields and the ability of those roots to function in the way that they normally would. So you can see in the no-till environment, anything that's red is bad, basically. So we wanted to really break that up and provide a good seed bed. So we ripped it at 8 inches with our strip till implement, and we can see this shatter zone, this U, which really looks good when we put the seed in there, because we go and think about that root system that's going to develop. So we feel like if you're looking to adopt subsurface placement, really understanding the seed environment and the ability of those roots, what's going to happen when you place it in the ground. If we combine that with our fertilizer application, where is this encouraging plant growth? In our no-till environment with broadcast application or broadcast and incorporation at a very shallow depth, there's some opportunities for those stratified soils to develop. And you can really see how those nutrient concentrations could build over time. If we think about this from the cross section, we're placing fertilizer below the surface, directly below the seed. Where is that really encouraging our root growth? In those stratified soils that are highly compacted, we're probably going to have more lateral growth. And whereas if we have a good seed bed and a good placement of fertilizer within that seed bed, probably have a more uniform distribution of roots throughout that strip. Now if strip till is not okay with you and you just want to look at some type of fertilizer application, still think about where this fertilizer is winding up. If you're doing one of those high-speed injection type of applications, that your nutrient band would be a little bit higher, but your tillage component will look the same as the graph on the left. So these are just things to think about as you maybe possibly move towards subsurface placement or contemplating it. These are some stuff that we've found to be helpful in our decisions for nutrient management looking forward. So the nutrient uptake aspect, we took a V5 corn plant, and we didn't do any actual studies on this, but we just wanted to simulate the root ball and where that fertilizer would be in relation to it based off of our application. So if we're really putting that P or K or whatever nutrients that we feel like the plant definitely needs in the middle of that root zone, just thinking about it from an environment standpoint, it's really promoting positive root growth. There's been some research around a lot of universities, Purdue and Iowa State have done a lot of subsurface placement, and some of those point to crop yields, but that changes depending on the field, on the previous tillage and crop operations. So we don't feel confident yet in putting a number on pounds per acre, bushels an acre of yield increase for subsurface placement, because that's going to vary from farm to farm. But in some instances, we've seen some yield boosts from moving applications below the surface. One of the things that we did, we evaluated the effect of planar downforce on our strip till for this past year, and we found that we've had a little bit better ride quality for our row units, and we really feel like that provides the best seed bed to plant into. So we've seen the opportunity of a little bit of planter performance increases there, and downforce definitely helps. If you're moving from field to field, your strips will change, and then obviously your downforce levels will be affected there. So compaction management, we touched on this a little bit with the case study earlier, but just a reference, we have a no-till environment, a 4-inch strip till and an 8-inch strip till here, and that you can see the compacted levels across each of these operations. So really the 4-inch strip till that we didn't talk about yet, we really missed that compacted layer. It didn't create that optimal seed bed. But when we got down to 8 and really ripped up the compacted layer that we knew was there, then we really started to see some benefits. So I got another question for you here, and that's what barriers to subsurface adoption do you face on your farm? So let's take a second to ask about that. And it's definitely tough. All of these time to get in after harvest, before planting, equipment limitations. Are these tools really the best for my farm? So it looks like equipment limitations and time are neck and neck there. But so hopefully some of this stuff today helped you. We didn't go into specific manufacturers, but available on our website in our publication, we have that information there. There's some outlined equipment options, as well as some considerations for moving to subsurface. So when we think about the implementation, we have those 4 aspects, but then what's the main attraction for some of these tools is the ability to reduce inputs. If we look at the field operations of a typical environment, maybe we'll probably have 6 or more passes within a year. We look at tilling, fertilizing, possible incorporation, and then plant and your management passes, spraying passes throughout the year, and then we have a final harvest. But what can we do with some of these tools that allows us to possibly move into a situation where we have 1 pass before the planter pass? And so we feel that if you can combine subsurface placement with the advantages that some of these tools offer, and possibly have that single pass before the planter, that's really where we feel the advantage is. So these are some things to think about as we move through. Just to sum it up here, we're finding that the equipment options that are coming down the line are really attractive to us. We think that it's only going to get better and easier to put fertilizer below the surface. Those options with the planter, we've seen late season in being applied with coulters. There's a ton of options here to think about as your operation moves forward, and how you want to adjust your nutrient management practices based on what fits your farm. Because it's not going to fit everybody, and it's going to take a lot of patience and probably some extra work to move nutrients in this way. But thinking about how you're setting up your farm for the long term and really building healthy soils and seed environments, we feel like there's some advantages there. So be excited for the innovations to come in this particular industry, and we certainly are, and we're planning some to continue the work that we're doing for this type of application. So big thanks to our sponsors. Greenfield Ag is out of Gibsonburg, Ohio. They've been great help. They got a booth out here, and they primarily deal with the shank-style strip-till implements. So appreciate Matt and Travis there and their work with us. So be sure to check them out today and tomorrow. And then we work with Salford and Orthman, and thanks to them for their support in case. This is the link to the publication there, so everybody can write that down if you would like to access. We're just outlining some different tools there. That's go.osu.edu/sub-surface. So we'll have probably some other publications up on our website soon that kind of outline other opportunities. So keep an eye out for that. And so with that, I'll take any questions. I put my contact information up there. And then we keep putting out our research and other facts out on our social media. So if you're interested, follow us there as well. So got time for a couple questions if anybody's got some. Hey, yep. In front.
What potential problem would be if you try to do, your soil test every 4 years, so if we try to put on 4 years nutrient in one application?
Okay, so the question was, you normally put out 2 years of spread of P and K, but what would be you soil sample every 4 years, so what would be the advantages of or disadvantages of putting out a 4-year spread? Well, I don't know if I can personally speak to that, but I would say that the kind of front part of my slideshow where we see the nutrient movement throughout the profile, I don't know if I would want to put out 4 years, just personally, but I mean that'd probably be something to consider with your agronomists, or so I don't have a concrete answer for you on that, but.
Do you have a link to some cost share advantages or opportunities for equipment, purchasing equipment?
Cost share. He asked for a link to cost share opportunities.
Cost share in some counties and areas.
Yeah.
We don't have a link up.
We don't have a
on our
link,
side,
but
there are links out there to get you those options or opportunities to take advantage of those cost share programs for this type of stuff.
Right.
yeah, there is a lot of opportunities for that, but we don't personally have a link. So. But.
Any other questions? Got one here.
Yep.
You patch part of 3-inch rows, that means those 15-inch rows. And if you go back to the same place all the time, what happens to green meals in that odd row?
Okay, so the question was 30-inch corn, 15-inch beans. If you're stripping in the same areas, how does that affect your bean yields in the rows in between the strips? I don't have data for that, but I would say one of the strategies that the guys at Greenfield and I were talking about was you take the first year when you're planting corn and you strip on the 30-inch rows, and then the next year strip again, move it over 15-inch so that you can compensate for your beans. So then your first row of beans is growing on your new strips, and then the next row over is growing on the strips from the year before.
Then you're putting the row of beans right down the row of corn balls.
Yeah. So it's definitely a challenge to kind of work out the logistics there, but yep.
Any suggestions how you take soil tests then in the future and get an accurate reading because you have cost of advance?
Right. So there's been some work out of, I believe it was Kansas State. The question was, how do you adjust your sampling protocol if you're doing subsurface application in a band scenario? So there's been some work out of, I believe, Kansas State and a couple other universities to look at that. And the idea was basically you take a higher ratio of samples outside of your strips compared to inside of your strips. So you would take more samples to get a composite sample. You'd take, I believe it was like a 3-to-1 ratio, 3 samples outside of the strip to 1 inside of the strip. So I have to go back and double check the numbers on that. But generally that was the idea. Yep.
You touched on reduced fertilizer for being more proper or precisely located.
Mm-hmm.
If you had a broadcast recommendation, what percentage do you think you do for a band?
So the question was about reducing fertilizer inputs if you're moving to a band, and I would say that we probably don't recommend a reduction, but if you feel like you're getting better nutrient uptake based on those applications, then that's something to consider if you move into strips. So I don't want to put a hard number on it. Yeah, we haven't done tests yet, but certainly something we're considering.